Now the same example for the using National Instruments components. What I have here is the compact DAQ of National Instruments. Let me zoom in there for you so you can see. There you go. And I'm using a digital input output module. As you can see here, it's got, just confirm, I think it's got 13 digital input and outputs. I've connected it to the digital input 0 and to the common, which gives my breadboard ground and provides the power. Now, the same with Arduino. I have the red light, the blue light, and the two current limiting resistors. Yes, I just wanted to give more clarity on the hardware that I'm using with National Instruments. So, let's check out this first. So this is the compact DAQ with its USB connector and power connector. USB connector, power connector. And it's got these 4 slots where you can insert the modules you want. Now the modules I used is this module, and it's a take a picture of that later on. High-speed digital input output module. Now I use this as a port expander, so I can plug it in and have nice screw terminals available for my input-output wires. So it's very handy. So I don't have this connector, I just plug that in, and I have the screw terminals available there. And you make sure it's right up, and I plug it in wherever I want. Okay, so this is the compact DAQ code controlling 2 LEDs through LampView. Now the front panel is pretty simple. We have 2 LED indicators and the stop button, which is this loop. The block diagram is also pretty simple. You have the main loop architecture here, and the stop button, which stops the loop, which is indicated here. So, how does this work? So, the same with Arduino code, basically. We start with a false flag outside the loop, which gets fed into a shift register. This value then immediately gets inverted through a NOT gate and then fed into the shift register at the end of the loop. So the next iteration, the inverse of the false, when it's been true, inverse false. So then these will be then fed back to our indicator LEDs, which are there and there. And also the Boolean value would get fed into a make array block, because this ExpressVI only accepts arrays, although it's 1x1 array, into the data slot, which then sends this value, true or false, to the compact DAQ and our specified digital output, turning on or switching off LEDs. Now, if I run my program, it takes a while to communicate, and there you see, same result as before. I have my LEDs blinking,
but just using now the compact DAQ of LabVIEW.